Probability IB questions number 2. In this question, they give us a table that shows the ages of people on a flight from London to Bangkok. So we can see we have a range of ages and the frequency, so the number of people that were within that age range. For part A, we're looking for the probability of choosing a passenger at random and finding that passenger is under 20 years old. So it says find the probability that the passenger is under 20 years old, which we have right here. We know that the probability of randomly choosing a passenger who's under 20 years old is equal to the number of ways that we can choose that passenger that is under 20 years old divided by the number of total ways. If we add up the number of total ways, we have to add up 28, 36, 20, 32, and 18. This will give us a total of 134 passengers. We can see from our chart here that there is only one age range that's going to fulfill under 20 years old, and that's this first one. So this probability will be 28 over 134. If we move on to part B, we're looking now for the probability of choosing a passenger who is over 40 years old. We know again that the probability is going to be the number of ways that we can choose a person who is over 40 years old over the total number of passengers that we have, which again we found to be 134. Well, now there are a number of different ways for us to choose someone who's over 40 years old. We have a number of different ranges. These are all right here. We can choose someone who's in the 40 to 50 range, 50 to 70, 70 to 100, which means that we have to add up 20, 32, and 18. So this will equal 20 plus 32 plus 18, and we're going to divide this by our total number, which was 134. And again, I know you're working on your calculator with this, and you will find, you probably already have found, that 20 plus 31 plus 18 is going to be equal, well, to 70, and we're dividing 70 by 134. And of course, on your test, you will be expected to either reduce this fraction. You can also put it into decimals, or you can put it into percents. In this case, I'm going to put it into percents, and I'm going to say, well, this is approximately, we'll say it equals that. I'm going to say that this is approximately equal, and you've probably already found this on your calculator, to 52.2%. Alright, moving on to C. We're saying, alright, we're looking for a passenger, the probability of choosing a passenger who's over 70, given that the passenger is 20 or over. This time we can look at the population and say, okay, well, how many people are 20 or over? That is right here on our chart. We know that anyone between the ages of 20 and 100 is 20 or over. So we add 36, 20, 32, and 18, and that will give us 106. So we know that there are 106 passengers that are all over, well, 20 or over. But what we're looking for is the probability of choosing a passenger who is over 70. So we can take a look at this and say, well, I know that the only time we're going to pick a passenger who is over 70 is going to be if they're in between the 70 to 100 range, and there's 18 of those. So we use this knowledge and we can say, well, I know the probability of someone being over 70 given that they're over 20. Well, this is the population that's over 20. We know there are only 18 who are over 70. which gives us 18 over 106. We can also use our conditional probability formula, which states the probability of A given B is equal to the probability of A and B. Remember, this right here is and, all divided by the probability of B. Putting this into words that fit our given problem in number 2, it's the probability of over 70 given, or over 20. That's equal to the probability of over 70 and over 20, divided by the probability over 20. Well, we can find the probability of someone being over 70 and over 20. It's going to be 18 over 134. Just those 18 passengers that fulfill what we're looking for. Only 18 of these are both over 70 and over 20, over our total population of 134 passengers. The probability of a passenger being over 20, we already figured that out over here. We know that there are 106 passengers who are over 20 out of our total population of 134. That gives us 106 divided by 134. Well, we can plug this information in, so we just have to plug in this and this into our formula that we wrote down. Once we do that, we find all of this jazz. So we say 18 divided by 134 divided by 106 divided by 134. Here you will find that we end up with 18 divided by 106. Again, on your test, any quizzes, it's important that you reduce these fractions. So this is equal to 9 divided by 53. Here, and up here. You can either leave it in fractions, you can put it in decimals, or you can write it out as a percent. All 3 ways are valid.